Hey guys, this is 5.4 lesson over similar triangles. So as a warm-up, we want to list all the three sets of congruent angles. So just a reminder, similar triangles have congruent angles, or congruent corresponding angles, and they have something called proportional side lengths. Okay, so listing all the angles, the way that I like to do it when I'm giving especially three sides, obviously the 90 and the 90-degree angle are easier to match. But another way to think about it is if I have a small, medium, and large side, and then the corresponding small, medium, and large sides, that can help me with determining where my congruent angles are. So for example, angle A is congruent to, so angle A is in between the medium and the long side. So in between the medium and the long side is angle J. Angle B we know is obviously congruent to angle G, just based off the 90-degree angle. And then angle C is congruent to, so angle C is in between the small side and the large side, so the small side and the large side would be angle H. The proportional side lengths are a little bit different. Remember, sides have two letters that notate them, so I'm just going to list out the three side lengths that I have for my bigger triangle. Okay, BC, and then I got CA. And those are proportional, meaning I can create these little ratios, and all those ratios will reduce to the same thing. So side AB is the medium side. So the medium side on the smaller triangle is side JG. And side BC is going to be congruent to side GH. Or sorry, not congruent, proportional to side GH. Side ACA is going to be corresponding to side HJ. So whenever you're setting up your similar triangles, you want to write these three proportions. Okay, what is the scale factor? So I can do that between, if it doesn't explicitly tell me which one to go from the bigger to the smaller one. So let's say if I'm going from the big triangle to the small triangle, that means the small triangle is technically my image, and the big triangle is my pre-image. So I'm going to use the 10 because that's an even number. And I'm going to say, so the big triangle, so remember your scale factor is image over pre-image, which equals your image is going to be 5 over 10. So your scale factor is 1/2. So from the big triangle to the small triangle, I would multiply each side length by 1/2. My similarity statement talks about my actual triangle. So triangle ABC is similar, that's the notation, remember, for similar, to triangle JGH. Okay, so when I ask for a similarity statement, it's looking for you to list those triangles. Okay, so, and these are some things that we've already done before, but we're solving for missing sides, knowing the side lengths that we have that are corresponding given the similarity statement up top here. So KML corresponds with RS. RS we don't know. So ML is 91, RS is going to be our X. And since these are similar, I know that the proportions have to be equal. So I have KL that I haven't talked about. KL corresponds to, so KL is to TS. So KL is 130, TS is 50. So from here we are just cross multiplying. 91 times 50 equals 130x. 91 times 50 is 4,550 equals 130x. Divide by 130 on both sides. X equals 35. And I think we've done this example before in a previous video. But for this guy here, I know NS corresponds to US. Since they're similar, they are proportional. That means that MS corresponds to TS. So I have 4x over 77 equals 36 over 63. And something that I want to make sure that you remember is that these values, 4x and 36, NS and MS, it's consistently on top of the proportion. So you don't want to get them mixed up because then you might mess up your actual cross multiplication. So 4x times 63 equals 36 times 77. 36 times 77, 2,772 equals 63 times 4, 252x divided by 252 divided by 252, x equals 2772 divided by 252 is 11. X equals 11, but what if I wanted to actually find what the side length of NS was? So NS is equal to 4x, so I can just plug that x that I just solved for and find the length of the NS. All right, so this is kind of all just review what I just talked about here, but now we're going on to similar triangles. So there are 3 different types of similar triangle theorems. You have angle, angle, side, and side, side, side. So this is kind of where you're thinking, okay, wait a second. This sounds a lot like congruent triangles. But here we're talking about similar triangles. So if we can prove that 2 angles and their corresponding angles are congruent, that's enough to prove that triangles are similar. So notice here I've got the 55, I got the 55, I got the 48 and the 48. As a reminder, triangles, the triangle sum theorem tells us that triangles add up to be 180 degrees. So what if I wanted you to find this length, or maybe I gave you that length instead of the 55? Could you solve the entire triangle from that triangle sum theorem? So CDE, so C corresponds to the E. Oh, I'm not looking at the right one. CDE, sorry, C corresponds to the W. D is going to correspond to the V, and E corresponds to U. So that's my similarity statement. So you should be able to know how to write a similarity statement using the triangles, because that's going to help you when you actually start to work with proofs. Similarity statement. All right, now we have side, angle, side. So before, side, angle, side meant 2 congruent sides, 1 congruent angle. But now, for similar triangles, sides are proportional. So what you have to be able to do is take the small, the medium side, take the small and the medium side, and you have to verify that the proportions are true. You have to verify. So I'm going to do the blue triangle on top. So I've got my small side over my small side of the red one. Okay, and I'm testing. I don't actually know, but I'm testing to see if the medium side of the both triangles are going to produce the same proportion. So when I do 40 divided by 24 in my calculator, I get 1.666667 repeating. When I do 50 divided by 30, I get the exact same thing. It must be the exact. Once I've proven that those proportions are the same, that means, yes, I've got 2 sides proportional. But here's the tricky thing, is I don't actually see an angle marked on this picture. But you must remember that we have these vertical angles. Therefore, we have side, angle, side. Angle F is going to be in between the medium and the small side, so angle F corresponds to angle F. Angle B, so we travel down the small side to get to angle B. So traveling down the small side of the blue triangle is going to get us to angle G, and the remaining one would have to be H. All right, so that's side, angle, side. We have angle, angle, side, angle, side. Now I'm looking at side, 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 which again previously meant that we had 3 congruent sides. However, now we know that similarity means we have 3 proportional sides. So if you can prove 3 proportional sides, then you have side, side, side. So I like to label the small, medium, and the large. That's just an easy way for me to organize my work. I'm going to do it different color actually here. Okay, so I have the small, the medium, and the large side. All right, so it doesn't matter which one you put on top, because if I put the blue triangle on top or I put the blue triangle consistently on the bottom, it's going to give me the same proportion either way that I set it up. So just a reminder, this was my small, my medium, and my large side. So the small side of the red one is 11. The medium side of the red one is 12. and the medium of the large side of the red one is 13. 44 divided by 11 is equal to 4. 48 divided by 12 is equal to 4, and 52 divided by 13 is equal to 4. So notice that all three of those proportions reduce to the same thing. That means they are similar by side, side, side. So angle U is in between the large and the medium. So the large and the medium is angle E. V is in between small and large, so in between small and large is D, and then we have F remaining. So that's the three triangle proportional theorems that you're going to, similar theorems that you're going to have to be able to identify given different triangles. So let's look at some examples. I'm looking at number 1. I see the angles and I see two sides. So these can be pretty easy to identify which one you think it's going to be. So I think it's going to be side angle side, but I have to test the proportional side lengths. I got the angle verified with the vertical angles, but I have to test it. So I've got the small, the medium, 8 over 18. Does that equal 11 over 18? 11 over 22. So 8 over 18 is 0.4444 repeating. 11 over 22 is equal to 0.5. These proportions, this is why it's so important to check them. These proportions are not equal. Therefore, this triangle is not similar. So you have to check those proportions. All right, so for our next one, we've got two different triangles. So this one can be kind of tricky to see the two triangles that are within. So you have this small triangle, and we can find all those side lengths. I said 21. Okay, so if this is 55, that means the remaining piece here would be 33. And if this is 45, subtracting 18 would give me 27. So the small, medium, and large of the yellow triangle is 21, 27, and 33. So we have 21, 27, and I'm checking to see if these proportions are going to be the same. So 33. Now the small side, so then I have my big triangle. So here's my big triangle. The small side of the big triangle is the 35, the medium is the 45, and the large is the 55. So I have small goes with small, 35, medium, 45, large, 55. And I'm checking those proportions in my calculator to verify. And I have to check each one of them, because if one of them is off, then the triangle's not similar. So 0.6, 27 divided by 45, 0.6, so far so good. 33 divided by 55 is going to be 0.6. So this one is similar by side, side, side. Now there's one more thing that I want to show you. So these triangles here are actually sharing this angle right here. They're sharing that angle by the reflexive property, because the angle itself is laying on itself for the small and the large triangle. So we could also say side angle side. Okay, looking at this next one, number 3, I've got one congruent marker to congruent, and then I have a 2. This one says 3 lines, 3, which means I don't actually show two angles that are congruent. So this guy is not similar. Okay. Number 4 is this special kind of property. We have, again, the vertical angles. And just think to yourself, what did I continuously say when we were learning congruent triangles? I said, what happens when you have two parallel lines? When I have two parallel lines cut by a transversal, I have all these different kind of postulates that come up. So in this case, do you guys remember what these two angle relationships are? You may be saying it out loud, super expressionally, but you have alternate interior angles, which means that I could say that this angle right here is congruent to angle G. Therefore, this is similar by angle, angle. All right, the next one, I see 3 sides. I don't see any angles, but I have to double check. So I've got my small, my medium, my large, my small, my medium, my large. So I'm going to do the triangle on top, say that with the on top proportion. So 16, medium is 20, large is 26. Divide by the 8, 10, and 12. I'm already sad because I know 16 divided by 8 is 2, 20 divided by 10 is 2, but 26 divided by 12, that is not equal to 2. Therefore, not similar. So it can kind of be tricky. Like that said yes, yes, and then all of a sudden it's like, no, it's not right. So you have to check all 3 of the proportions to verify. Okay, this one I see 2 side lengths. So remember, sides will be outside the triangle. Angles will be inside. So I'm looking at this and I'm thinking, I think you're side angle side. But I have to check those proportions. So I have my small, my medium, my small, my medium. Okay, I see the angles congruent, so I know I've got the angle. So I'm just going to set up those proportions just to verify. Okay, I'm going to plug that in my calculator. So I'm going to do 24 divided by 56. That gives me 0.42857, etc. 39 divided by 91 gives me 42857, etc. Those, yes, are proportional, therefore similar by side, angle, side. So just an important kind of quick thing to remember. You have to double check when there's side lengths. You have to verify that they're proportional, because that's going to be the easiest trick to make you miss, is that I'm going to give you maybe a proportion or side lengths, but one of the side lengths will not have a proportional relationship. So that's your similar triangles. It's important to get these similar triangles because we're moving on to proofs.